A little video for those that are writing Uniben utme to bring your attention back to something. Yes, you must have been preparing for the exam very well, of course, but there are some little areas and one or two questions that I just want to share with us to bring your mind back to those topics that you should pay attention to them. Of course, pay attention to all areas, all topics. For instance, I do not want to waste much time. The video is just 30 minutes or 1 hour, or depending. I don't want to waste much time. Like if you see this kind of question now, I'm not saying that this is the exact question that will come out in the examination, but I'm saying that questions like this, you should focus or pay attention to them. Now, if I'm having a question like this, now they're asking me, which of the following has the greatest ionization energy? Now, something is coming to your mind, yes, that you should look at properties that affect elements in the periodic table, talking about ionization energy, talking about electron affinity, talking about electron negativity, talking about atomic radius or ionic radius, electropositivity, and of course metallic properties. Now, dealing with ionization energy, at this time I believe that you ought to know what ionization energy is the energy needed to remove an electron from the outermost shell of an atom. Now, there's the variation of ionization energy with the periodic table. How does it vary with the periodic table? Now, as you move across the period, when you move across the period, ionization energy does what now? Increase across the period, but decrease down the group. Ionization energy increase across the period, but decrease down the group. That means to say, if I'm moving from group 1 to group 2 to group 3 to group 4 to group 5 to group 6, group 7, group 8, what's happening to ionization energy? Ionization energy is doing what? It's increasing across the period. Now, look at the options provided. Helium, argon, xenon, krypton. If you notice very well that all of these elements here are noble gases, that is to say they are found in group 8 or group 0 if you like, that means they have a complete configuration. Now, this helium, of course, is first in group 8. That means if you are moving from across the period, ionization energy increases, but if you are moving down the group, ionization energy decreases. That means if I'm moving from, look at the arrangement now, that means if I'm moving from for instance, helium, neon, argon, krypton, xenon. Now, if I'm moving from top to bottom, what is happening to ionization energy? Ionization energy is doing what? Is decreasing. So from this particular question, the element with the greatest ionization energy is what? Is helium. So what's this thing trying to tell us? That we should be very careful and be mindful of properties that affect elements in the periodic table, that you should look at it. Of course, you should know that the following properties: ionization energy, electron affinity, electron negativity, electron positivity, all these properties tends to increase across the period. Now, but when it comes to atomic atomic radius and metallic properties, what happens to these guys? What happens to them is that what's the variation? What variation they have with the periodic table? As you move across the period, they do what? They decrease across the period. Now, look at these other questions. I just want to share few things with you. So, as you are studying now, you need to look at, I need to look at properties that affect elements in the periodic table. So I need to look at those properties. Now, look at this other question. They said, which of the following actinide is commonly used as a nuclear fuel? Now, there is no option here, but one major actinide. Now, when you hear the actinide, something will come into your mind. Now, you have heard of the lanthanides and the what? And the actinides. Now, if you have been studying, you pay attention that the lanthanides and actinides are in period 6 and what? And 7 of the periodic table. They are in period 6 and 7, the lanthanides and the actinides. Now, these lanthanides and actinides, first of all, they are F block elements. You should know that they are F block elements, or they are also regarded as inner transition elements, and most of those elements are what? Are radioactive. And because they are radioactive, they are usually used as what? As fuel. Now, one common actinide that is used as fuel in nuclear reactors is what? Is uranium. You see now, so uranium is what? is an actinide that is commonly used as fuel in what? In nuclear reactors. Now, all these kind of questions, you need to pay attention to them as you are studying, as you are doing your last revision for the examination. Now, which other areas that I want to point out again, I should be very careful with when you are studying for this exam? Separation techniques. When I say separation techniques, separating salts, not just knowing evaporation, crystallization. So for instance now, if they give you something like this, a mixture of, look at this one that you should try, a mixture of sand, look at it, a mixture of sand, ammonium chloride, a mixture of sand, ammonium chloride and sodium chloride is separated by which techniques? Pay attention to that. Now, for you to know how to separate salts, you need to pay attention to solubility of salts. Solubility of what? Of salts. You need to pay attention to it. Like, what do we mean, Mosjaro? Solubility of salt, what are you talking about? Now, how do you know salt that is insoluble or soluble in water? Now, those salts that are soluble are usually you need to know the method used to collect them, and also salts that decompose on heating. Now, insoluble salts are usually separated by filtration. Those salts that are insoluble. So if I dissolve it in water and it's insoluble, of course, depending on the mixture I have with the mixture of salt that forms or different salt that form the mixture, I will now know which method to use. But pay attention that salts that are insoluble in water are usually separated by filtration. Salts that are decomposed on heating, of course, you should know, are separated by crystallization. Now, if we have known, now I've drawn out 3 things for you to pay attention to. Number 1, what's the first one? You must know properties that affect elements in purity. You put at the back of your mind. Now, sometimes, like I was telling somebody not too long, that you might get to the exam and you might not see any question that you are familiar with. Like, the questions might be strange, but it's for you to settle down and look at those questions very well. Not that it's really strange, just that you have to apply all the knowledge that you have gathered in chemistry over time. So I'm bringing your mind to something now. You want to bring out calculations for you. Look at the calculations that you should pay attention to, that you should do your revision on, of course. Now, if I want to check out calculations, now you begin to ask yourself, what are the formulas that I should be looking out for now? All the formulas on gas laws, all the solvings on gas laws. Especially, my mind is telling me, especially Avogadro's law. Like when they will give you mass, they will say calculate the number of atoms or calculate the number of molecules that is found in so and so. You have to remember, first of all, how to convert number of moles to, mass to number of moles. Then how you can relate moles to Avogadro's number. For instance, you remember this, that 1 mole of any substance contains 6.02 times 10 to the power 23 atoms or what, or molecules. Now, all the gas laws, all the formula on gas laws, Graham's law, ideal gas equation especially, you should look at that. Then again, another area that you should look at their formula again is solubility. How to calculate solubility, of course, this formula should be at the back of your mind. How to calculate solubility in where? In moles per dm cube. That solubility is equals to mass of solute over molar mass times what? 1000 cm cube over what? Over volume of the solvent given. Now, you should put this formula at the back of your mind in case you see questions on solubility or for you to solve. Now, also remember that there are some factors that affect solubility. Of course, temperature, pressure, concentration affects solubility. But remember that pressure usually affects solubility of gases. That the higher the pressure, the more soluble the gas becomes. Now, when it comes to temperature, the higher the temperature, the higher the solubility of a solid. But when it comes to gas, the higher the temperature, the lower the solubility of the gases. Now, you pay attention again in the area of the organic chemistry. The organic aspect of chemistry is very important that you look at it. Sorry. Now, if you want to look at organic chemistry, what should I be looking at? Alcohols, the homologous series, the alkanes, the alkenes, the alkynes. Which other area again? When you talk about the alkanes, for instance, you should know the alkanes. Okay, for example, now, which alkane causes explosion during mining? Of course, you should know the answer is methane. Which alkane is the most abundant alkane in domestic cooking gas? Of course, is butane. Now, all those kind of questions, you should put them at the back of your mind. Now, what about the aspect of the metals? What about the aspect of the non-metals? Of course, if you are looking at the metals, a quick revision now, you pay attention to extraction of the metals, purification of metals, non-metals, oxidizing agents, reducing agents, buffer solutions. For instance, now, of course, you should know this. This question is common in post utme. I don't know what they see with this kind of question. Now, if I have something like this now, say HCl plus H2O, now give me H3O plus Cl minus, for instance. So we say in the equation above, chlorine is the what? Of course, this is the acid, and this chlorine and this HCl, what's the difference between them is that this HCl is one proton lesser than this other guy. It's one proton lesser than this guy. Now, because of that, this chlorine is a conjugate base. So what's the essence of this video? It's just for you to sit back again and observe and say, okay, have I touched this? Have I touched this? And if you have not looked at those areas or these areas I'm pointing out now, you should just quickly go through them, of course, and keep your mind abreast with all the information involved. Now, which other thing than Mosjaro? What do you think? Atoms, configurations, you should pay attention to them, like configurations, principal quantum number, azimuthal quantum numbers, those groups, period, paramagnetic elements. Of course, you know what a paramagnetic elements that have one or more unpaired electrons, diamagnetic elements that do not have unpaired electrons. How to calculate oxidation number. Put it at the back of your mind. You need to go and do your revision on those areas again. How to calculate oxidation number. Then, let me see, I have a few questions here that I would like to just try and check out. Like this one, and they say, what's the importance of sodium aluminate 3 in the treatment of water? The use of sodium aluminate 3 in the treatment of water. They said option A, neutralizing acidity. No. One common compound that is used in the neutralization of acidity is calcium hydroxide in water purification. The other one is say prevent goiter and tooth decay. No, that one is done by the addition of fluorine to prevent tooth decay. Now, to kill germs, of course, chlorine can be used to kill germs in water purification. Therefore, chlorine is used as a disinfectant, so to say. Now, look at it. The option D here says coagulation. Of course, that aluminium tetrasulfate, aluminium 3 tetrasulfate 6 is a double a double salt. That sodium aluminate 3 is a double salt, and of course, is used in coagulation, just like alum, potash alum is used in coagulation during water purification. Now, all these kind of questions, now they say which of the following, okay, see this one, which of the following noble gases is commonly found in the atmosphere? That one is a very simple question. We're talking about argon. All these kind of questions, you should pay attention to them. Don't fail to look at the organic aspect of chemistry. They are very, very important, but check them out. Mosjaro, of course, fine and heavy chemicals, you should know them. Example of fine and heavy chemicals. I keep on sounding it again. Separation techniques, very, very important and necessary. So, ladies and gentlemen, this is just for you to sit at your convenience and at your comfort zone and just take a rewind and say, okay, have I touched this? Have I touched this? Have I checked out this? It's very necessary. Sulfur and its compound when it comes to non-metals, the halogens, the nitrogen and their compounds. I'm very fast, but it's just a short video to bring your mind to something very, very important. So look at it now. I've been able to point out some maybe gray areas. Of course, nuclear chemistry is very, very necessary. Now, something is coming into my mind in this calculation aspect. You should also remember how to calculate what? How to calculate half-life. How to calculate half-life. Half-life is equals to 0.69 multiplying thing over what? Over decay constant. And you should also know this again, that n is equals to n naught bracket